Hi, and welcome to Meetings in Math. You are here for lesson 6.5, Analyzing and Sketching Graphs. Our essential question is, how can graphs be used to represent relationships between quantities without using numbers? You'll need your Jaguar Jots on section 6.5, a pen or a pencil. You might find a highlighter helpful, your problem-solving skills, and today, bring that inspiration with you along with some bright ideas. Today we'll be looking at independent versus dependent variables. This is how all graphs start off, with this idea of your independent variables is on the horizontal axis and your dependent variable is on your vertical axis. In the center is where your graph goes. They're read from left to right increasing and top to bottom increasing. The independent variable, this is the information that we have, the things we control, usually times and days. The dependent variable is usually what we want to know, but need to know information in order to know it. And it's usually money. So for example, if I told you that if I work for 3 days, I'm going to earn $500. So 3 days, and then I go up and then I read across and I said, oh, I earned $500. So that's how graphs usually work. So let's look at these two different graphs. The graph shows the temperature throughout the day in two cities. Describe the change in temperatures for each city, and then we're going to make some comparisons. So let's look at Oakton. Oakton looks like we're increasing and then we're decreasing. And Charleston does the same, but in a different way. So here Oakton does a increase and then it starts to decrease. But our increase is a gradual, and then it quickly decreases, and then it stops. But if we took a ruler and we keep it nice and parallel, and let's just draw a line now, we can even see that we don't get back to our starting part. So that's one of the things that maybe we want to talk about. So the temperature increases, then it starts to decrease, and then it keeps decreasing rapidly, right? This was a gentle curve, and then this is really fast. If you think of you were on a roller coaster, that'd be pretty fast. That's kind of how I start to think about things. So the temperature increases gently, then starts to decrease and keeps decreasing rapidly, but doesn't reach the starting point. So that's one way you could describe it. Somebody might describe it a little bit differently, but that's the general way we should describe it. So now we look at this and we find ourselves, how do we describe this scenario? So obviously we are increasing because it is going up. And then it increased very, very quickly because it shot up. So we had a general increase and then a very quick increase. What's happening here? Well, the temperature is not changing because it's not going up anymore. But time has to march on. And so time is going on. So the temperature is holding steady here. And then it does a sharp increase. And it does look like we probably ended about where we started. So the temperature increases at a constant rate. See how this isn't constant? It curves. This here's a straight line. So it is a straight line. So it has a constant rate and a constant rate. So the temperature increases at a constant rate. Then it increases at a faster constant rate. Then it stops changing for a time. And then it decreases at a fast constant rate. So this one's all about constant rate, where this one's about these like gentle, and then it's decreasing rapidly, but there's a whole lot of other things going on. And so now we're supposed to talk about three comparisons from the graph. So one thing is, both of these graphs had increasing and decreasing. The other thing is what? They're both nonlinear. While Charleston had linear parts to it, as a whole, it is nonlinear because it went up and it went down and it went straight across and it did all kinds of things. So they are both nonlinear. Oakton has no linear segments. Charleston has 1, 2, 3, 4 linear segments. So that's one way they're different. And what else would you say? It has to do with this part right here. Oakton ended warmer than it started. Charleston ended about the same. So even though there's absolutely no numbers on this, we have lots that we can talk about. We can talk about how did they change. We can talk about even warmer and colder. I don't know exactly if Oakton is warmer than Charleston or not, because we don't have that much information, but I can talk about the types of changes that they had in comparison to one another. I would challenge you to see, can you come up with any other things to say about this? So in these next two examples, what we're going to be doing is making the graph that goes along with the words. I'm actually going to challenge you to make that graph before I do. But let's get the axes set up. A soapbox derby picks up speed at a constant rate while it travels downhill. It continues to pick up speed until the racer applies the brakes after crossing the finish line. Once the brakes are applied, the car decreases speed at a constant rate until it stops completely. So we are definitely looking at speed versus time. So time dictates how fast we go. So what I'd really like you to do is I would like you just to take a pencil and sketch on what you think, and then I would like you then to maybe take a pen and sketch in the answer I give you. Because understanding what you thought and then what I gave you for an answer is really going to help. Okay, so now that you've done that, let's talk about this. We're going to pick up speed at a constant rate. So because I said constant, I'm hoping that you remember constant means a straight line. So we're going to pick up speed at a constant rate as it travels downhill. So most of our brains think traveling downhill means I need to make a line that goes downhill, but that's not what we're doing. We're picking up speed. To pick up speed, I need to go up this line, and I am traveling in time, so I'm going that direction. So I need to pick up speed. I need to go faster. And now here's my finish line. Let's say right here's my finish line. I need to apply my brakes. Well, I'm going to apply my brakes much faster than I picked up speed. And so it's going to go like that until I stop. Because it says I picked up speed at a constant rate as I traveled downhill. And I pick up speed until I apply the brake after crossing the line. So right here is where I crossed the finish line. And then I applied my brakes. And then I stopped completely. So this is where I stopped. That's why I'm at 0. My speed is 0 now. So it's totally not what our brain is thinking. Our brain wants to make the picture of going downhill, which means we want to go downhill. But we have to start here where our speed was 0. Then we increased our speed over time. Now our speed has to decrease over time, but it has to do it super fast. So now let's look at the last one. As the price of a product increases, the amount of the producer's supply increases at a decreasing rate. Okay, this is supply and demand. So supply and the price. As the price of the product increases, the amount that the producer's supply increases at a decreasing rate. So we're still going to increase, just not as fast. So we're not looking at linear anymore. We're looking at something different. So go ahead, pause that, puzzle it out a little bit, and then come on back. So we're still increasing, but we're increasing at a decreasing rate. So how can I still increase but slow down? The only way I can increase but slow down is to curve. So I still need to increase over time, but not quite so fast. So I'm doing really, really good, and then I need to slow that increasing down. So I'm still increasing, but not as fast. These are tough, and they take time to understand. So what I'm going to challenge you to do is I'd like you to find a news article or something that talks about time versus money or time versus supply or any of that. Find something in real life and see if you can draw a graph that goes along with it. Thank you so much for showing up today in our lesson. And remember, be kind to one another because we can all use some extra kindness in our lives. Bye for now.